Good morning students. In this video we will discuss about conic section or simply conic. What is a conic section? What are the different types of conics? Most of the students feel this chapter difficult, but it is very simple if you follow in order. Let us see actually what are the conics. What are the conics or conic section? If a cone is cut by different surfaces, then there exist some curves. Those curves are called conic sections or simply conics. So please see, I will take a cone, of course a double napped cone. Say this is a cone. Say this is a cone, double cone of course. And also I will take a surface or a plane. Now I will cut this cone by this plane, this surface in different positions. See Nana. So if I cut this cone using this surface, for example, you imagine this is a fruit, this is some carrot, this is a metal plate. I will cut this plane like this. Then I will be getting here a curve like this, which is a circle. I have cut this horizontally. I have cut this horizontally. I have cut this horizontally. Therefore, if I cut this, I will remove this. What will be the shape over there? It will be a circle. I have cut horizontally. Instead of horizontally, if I cut with little bit inclination, then what will be the curve over there? It will be like this. This is also a curve, which is a conic. If I cut this one like this, for example, if I cut like this, if I cut this, if I remove this portion, what will be the figure there? It will be a figure like this. If I cut this like this, so I will cut this portion and this portion. What will be the figure over there? Like this. Two different branches. So these are the curves obtained by cutting a cone by different surfaces. These are called conic sections or simply conics. So what are conics? The curves obtained by cutting a cone by different surfaces. Those curves are called conic sections. Now we will see its systematic definition. Now I said what is a conic section. Conic section, it is a curve obtained by cutting a cone with different surfaces. I said conic sections are curves. So now we will define it in a systematic way. So I said conic sections are curves. What is a curve in 2D geometry? Every curve is a locus. Therefore this conic section is also a locus. We will see the systematic definition. Please listen carefully. What is the definition since it is locus? See Nana, see carefully. The locus of a point, in a plane, the locus of a point in a plane such that the ratio of its distance from a fixed point to the perpendicular perpendicular distance to the perpendicular distance from a fixed line is a constant. The locus of a point satisfying this condition is called a conic section. Or simply a conic. Yes, this is the definition. Very simple. What is the definition of a conic section or simply a conic? Since it is a curve, it is the locus of a point. The locus of a point in a plane such that the ratio of its distance from a fixed point to the perpendicular distance from a fixed line. What is curve? A conic section is a curve. It is a locus. Every curve is a locus. Locus means it is a union of points, set of points satisfying some condition. So the definition says conic section is what? The locus of a point in a plane such that the ratio of its distance from a fixed point to the perpendicular distance from a fixed line is always a constant. What should be the ratio? That ratio should be a constant. The locus of a point satisfying this condition is called a conic section. This is the definition. So we will try to explain this in a simple way. Take none. So this is a plane. I will take a fixed point. Let capital S be a fixed point. That point, it can be any point, origin or any other point, no problem. A point in first quadrant, second, third, a point on x-axis, y-axis, wherever it can be. Let capital S be a fixed point. And I will take a fixed line. This can be any line. So what is L? L is a fixed line. S is a fixed point, L is a fixed line in space. Now, the locus of a point capital P. What is conic? Conic is a curve. Curve means it is a locus. Therefore, the locus of a point P such that the ratio of its distance from a fixed point means this distance to the perpendicular distance from the fixed line. Say this is PM distance, perpendicular distance from this. So the ratio of distance from a fixed point to the perpendicular distance from a fixed line, ratio of these two distances, I can write the ratio as what is the distance of the point P from the fixed point? SP. The distance from the point to fixed line is PM. So this ratio should be what? It should be a constant. Very simple. The locus of point P satisfying this condition is called a conic section or simply a conic. If you are not able to repeat this definition, if anyone asks you what is a conic, very simple. The locus of a point P satisfying the condition SP by PM equal to E. The locus of a point P satisfying the condition SP by PM equal to E is called a conic section. That's all. What is a conic section? It is the locus of a point P. What is conic section? I said it is a curve. What is a curve? Curve is a locus. Therefore, our definition should be Locus definition. What is the definition? The locus of a point P satisfying the condition SP by PM is equal to constant is called a conic section or simply a conic. That's all. This is the systematic definition of conic section. So far we have studied two-dimensional geometry, straight lines, pair of lines, circle, system of circle, etc. So here in this conic section there will be different terminology. Okay, we will study all the concepts one by one in a systematic order. Sequence and order is important. So what is a conic section? We have seen its definition, we have seen its explanation also. So this is conic. See now, here this fixed point is there. What is capital S? Capital S is fixed point. This capital S fixed point is called focus. This point is called focus of the conic. What is this? This is a fixed line, no? Fixed line L is called directrix. L is what? Directrix. This is called directrix. Fixed point is called focus and fixed line is called directrix. So what is this? SP by PM is there, no? So this SP by PM. In this ratio, what is SP? Distance of the point on the locus. Distance from the point to fixed point. What is this? It is distance. This is also distance. Both are always non-negative. Distance cannot be negative. So this ratio is also non-negative ratio. It can be 0 or it can be positive. This ratio is always a constant number. That constant is denoted by small e. What is the constant ratio? That ratio means you will get some real number, non-zero real number, 1 by 2 or even 1, 3 by 2, etc. That constant is denoted by e and which is called eccentricity. Which is called eccentricity of the conic. What is this? Eccentricity of the conic. So we have seen the definition. According to definition, what is a conic? Conic is a locus satisfying the condition SP by PM equal to constant. The fixed point S is called focus. The fixed line L is called directrix. The ratio, constant ratio is there, no, which is a non-negative number. So here E is non-negative, E is always greater than or equal to 0. This constant ratio, non-negative ratio, it is denoted by E and it is called eccentricity of the conic. Yes. Conic section, it is a locus. Just now I said satisfying the condition, simply SP by PM equal to E. Fixed point is called focus, fixed line is called directrix and that constant ratio is denoted by E, which is called eccentricity. Okay, now see, depending on this E value, what is E? Constant ratio, non-negative. Depending on this, conics are classified as, see Nana, if E is equal to 1, if the eccentricity is equal to 1, then the conic is called a parabola. What is a conic then? Parabola. Yes, if E is less than 1, if E is less than 1, E is, I said, non-negative, no, you can also write like this, 0 less than E less than 1 also you can write. In this case, if eccentricity, the constant ratio is a number less than 1, then the conic has given the name ellipse. It is called an ellipse. If the eccentricity is a number greater than 1, if it is a number greater than 1, then the conic is called a hyperbola. It is called a hyperbola. In some cases, E is equal to 0. If eccentricity is 0, what is eccentricity? SP by PM. What is numerator? SP. PM is denominator. It is a fraction. When a fraction is 0, if numerator is 0, 0 by something 0, that means SP is 0. SP is 0 means the fixed point coincides with P. In that case, this will give us a circle. So if E is equal to 0, then the conic is called a circle. It is called a circle. So if E is a number which is tending to infinity, if E is a number which is tending to infinity, then the conic is called a pair of lines. Pair of lines. So these are the types of conic sections. Circle already we have studied in detail. Pair of lines also we know that we have completed it. Now in this syllabus we will discuss about these three conics. These three conic sections: parabola, ellipse and hyperbola. So how to differentiate these three? Differentiation can be done using eccentricity. If eccentricity is 1, then the conic is a parabola. If it is less than 1, it is an ellipse. If it is greater than 1, it is a hyperbola. Of course, if E is 0, then it becomes a circle. If E is a number tending to infinity, then it is a pair of lines. Yes. So we have defined a conic. We have seen the different types of conics. Now we will know terminology of this section, this branch, this chapter. Already we have seen three new terms: focus, directrix, eccentricity. What is focus? Fixed point is focus. What is directrix? Fixed line. And what is eccentricity? The constant ratio, which is non-negative. Now we will see some more. See now. So we have seen these three now. What is S? S is a fixed point which is called focus. For every conic there will be a focus and directrix. So what is this line? This line is a fixed line. Yes, this is a fixed point and this is a fixed line. Yes, fixed point is called focus of the conic, fixed line is called directrix of the conic. That ratio SP by PM equal to E. That is what? Eccentricity. Okay, now let us know some more terms. These are all important. They work for all the three: parabola, ellipse, hyperbola. Okay, firstly I will write a definition. What is this first one? Axis. You can say axis or principal axis. Axis or principal axis. Yes. This is first definition. Listen carefully. What is axis of a conic? Very simple. The line passing through focus perpendicular to directrix. Listen carefully. What is axis? Axis is a line passing through focus perpendicular to directrix. This line. This can be any line, not x-axis. It can be x-axis or any line. So this is axis. It is actually principal axis. Simply we say axis. So what is this first term? Axis of a conic. Axis or principal axis. Next definition, vertex. What is a vertex? So we are in the beginning of the chapter. Just now we have seen the definition only. We did not know their figures, etc. But to understand better, I will draw some rough figures. Listen. First one is principal axis. We have seen principal axis is a line passing through focus perpendicular to directrix. This line is axis. This line. Now vertex. What is a vertex? Very simple. I am not writing on the board definitions. I am not writing. Orally telling. Listen carefully. Vertex. What is a vertex? The point where the conic means it can be any conic, parabola, ellipse, hyperbola. The point where the conic crosses the axis. Listen. The point where the conic crosses the axis is called vertex of the conic. What is a conic? It is a curve. It will have some figure, no? So the point where the conic crosses the axis. For example, I am taking a rough figure like this. Rough figure it is. Say this is a conic, you suppose. Where it is crossing the axis, it is crossing the axis at this point. Therefore, what is this? This is called vertex. What is this? This is vertex. Next, another definition. Chord. As usual definition, what is a chord? Chord means same usual definition seen in circles, etc. What is a chord? The line segment joining any 2 points on a conic. For example, if you join these 2 points on a conic, it is a chord. Similarly, if you join 2 more points, this is also a chord. Very simple. What is a chord? Chord is a line segment joining any 2 points on a conic. Yes. After this, next focal chord. Next term is focal chord. What is a focal chord? Very simple. You take circles. There will be many points on circle. Among those, some chords they pass through center of the circle. Such chords are called diameters. Here also there can be infinite number of chords. Some chords they pass through focus. See now. This is a chord. This is a chord. This chord is passing through focus. Therefore, it is a focal chord. See, another one. This is also a chord. And it is passing through focus. Therefore, it is a focal chord. What is a focal chord? A chord passing through focus is a focal chord. Next term. Latus rectum. Latus rectum. Next term is latus rectum. Next definition. What is a latus rectum? These are all most important. What is a latus rectum? A focal chord perpendicular to axis. What is a latus rectum? A focal chord perpendicular to axis. What is a focal chord? A chord passing through focus is called a focal chord. There can be many focal chords. Among those, one focal chord will be perpendicular to axis like this. Yes. See, this one is perpendicular to axis. These are all focal chords. How many focal chords will be there? Infinite number. Many focal chords. Among all those, one chord will be perpendicular to axis. What is axis? This line is axis. I said order is important. Firstly, axis. You should know axis better. What is axis? What is it? Then vertex, etc. Order is important. So what is latus rectum? It is a focal chord perpendicular to axis. This is latus rectum. How many latus rectums will be there? depending on the focus. If a conic has one focus, then there will be only one line passing through focus perpendicular to axis. If a conic has two foci, then there can be two. By all means, what is latus rectum? It is a line passing through focus perpendicular to axis. So this is latus rectum. Next one is double ordinate. Next term is double ordinate. Yes, double ordinate. What is a double ordinate? Ordinate means if you have given a point, y coordinate is called double ordinate. Okay. In general, all the conics, they are symmetric about its axis. We will come to know in the next classes. All the conics, they are symmetric about their axis. For example, if you take this curve, this is a rough figure I took for our convenience to understand better. This is a curve. It is always symmetric about its axis. This line is axis, no? Therefore, this is symmetric about its axis. So it will be at same property, same distance above the axis and below the axis. Yes, now the word is double ordinate. What is a double ordinate? For example, if you take a chord perpendicular to axis, then this distance and this both will be equal because of the symmetric property of the conic. So this and this are equal. For this point, what will be this? This will be y coordinate. This will be x, no? This will be y coordinate. This will be y coordinate of this point. So for this and this, y coordinates are same. Therefore, it is called a double ordinate. Yes, what is a double ordinate? Any chord perpendicular to axis. What is a double ordinate? Any chord perpendicular to axis is a double ordinate. What about latus rectum? It is also a double ordinate. This is also perpendicular to axis, no? It is also a double ordinate. So this is double ordinate. Next, focal distance. Focal distance of a point. Very simple. What is focal distance of a point? If you take a point on the curve, for example, if you take a point on the curve, say capital P is a point, the distance of the point from the focus, this distance is called focal distance of this point. If there is one more point here on the curve, what is its focal distance? Distance of the point from the focus. This is called focal distance. That's all. These are the terms which we will use in this chapter. Once again, I will repeat this. So, we have seen the definition of conic section, seen different types of conic sections. Every conic will have a fixed point which is known as focus, fixed line which is known as directrix. That constant ratio, non-negative ratio is denoted by E, which is eccentricity. Now some terms. What is principal axis? What is principal axis? The line passing through focus perpendicular to directrix. This line is axis or principal axis. Next one is vertex. What is a vertex? The point where the conic crosses the axis, where it meets the axis. This point is called vertex. Yes. Next, chord. What is a chord? Usual definition. The line segment joining any 2 points on a conic is called a chord of the conic. Next one is focal chord. What is a focal chord? It is also a chord but passing through focus. Chord passing through focus. A chord passing through focus is called a focal chord. Next term is latus rectum. What is a latus rectum? A focal chord perpendicular to axis. This is latus rectum. After latus rectum, double ordinate. What is a double ordinate? Any chord perpendicular to axis. How many double ordinates will be there? Infinite. Any chord perpendicular to axis is called a double ordinate. This latus rectum is also a double ordinate. Next, focal distance of a point. Every point on a conic will have some focal distance. What is focal distance? If P is a point on the conic, then distance of P from the focus. Distance from focus is called focal distance of this point. Focal distance will be defined for every point on the conic. This is also another point. Its focal distance is this length. We have forgot one more word, which is center of the conic. What is the center of the conic? Okay, see now. What is center? I said what is vertex? Vertex is the point where the conic crosses the axis. If a conic cuts the axis or crosses the axis in 2 points. For example, if there is a conic like this is a conic which is cutting the axis in 2 points. See, those 2 points where the conic is crossing the axis, they are called vertices. There can be one vertex or 2. So in this rough figure, the conic is crossing the axis in 2 points. In this case, the midpoint of the vertices, what is center? Center will be defined for the conics having 2 vertices. So center is what? Midpoint of the vertices. Midpoint of the vertices. If there are 2 vertices, then their midpoint will be defined as center of the conic. If only one vertex is there, then center is not defined. In that case, center is nothing but vertex. There is only one point. Yes, these are the very, very important. You should know the terms properly. Their figures also perfectly. Yes. Now we will see the equation of a conic. Listen now. Equation of a conic. Equation of a conic. You can say simply conic or conic section. Yes, just now we had a definition. No, what is a conic? For conic, there will be a fixed point called focus and a fixed line called directrix. According to definition, conic is a locus. Okay. So I am finding the equation of a conic. For example, the fixed point is alpha beta. Say it is alpha beta. And what is the fixed line? You suppose the fixed line is ax plus by plus c is equal to 0. This is the fixed line. Now I will try to find the equation of a conic. So equation of conic whose focus fixed point is alpha beta, directrix fixed line is this. According to definition, what is a conic? Conic is a locus. Therefore, I will take a point capital P x1 y1. Be any point on the conic. Be any point on the conic. I have taken a point on the conic. What is a conic? Conic is a locus. Therefore, I have taken a point. For every locus problem, there will be a condition, no? Yes. What is the condition here? The point which we have taken on the conic, on the locus, that will be such that SP by PM is equal to constant, which is E. Okay. So the condition, what is the condition? I should take SP by PM. The condition is SP by PM is equal to E. So we will simplify, we will put all the values in the condition. Okay. So cross multiplication SP is equal to E into PM. Okay. What is SP? SP means distance between S and P. What is our P? It is a point on the locus, point on the conic x1, y1, distance between those two. If you find this x1 minus alpha whole square, y1 minus beta whole square is equal to E into PM. What is PM? Perpendicular distance from P to this fixed line, this line. So what is perpendicular distance? We have seen in straight lines. Mod AX1 BY1 plus C whole divided by root over A square plus B square. So according to definition, conic is a locus. Therefore, I have taken a point on the locus. This is the fixed point focus, fixed line directrix, applied condition. This is the condition. So now squaring both sides and cross multiplication, I will get equation like this. X1 square, x1 minus alpha whole square, y1 minus beta whole square. This will be what? E square into ax1 by1 plus c whole square is equal to 0. Okay, this is the equation of a conic. Conic's equation will be in this form. So what I am trying to say is, I want to see the equation of a conic. What is its form? It contains which terms? Listen carefully. So finally we have to write the locus. To generalize the problem, you are supposed to replace x1 y1 by xy. I did it. Okay. Now can you say this equation contains which terms? Very simple. X minus alpha whole square is there. Here x and y are variables. A, B, C, E. They are all real numbers. On expanding this, there will be an x square term. Also, here you see there will be a y square term. Here a plus b plus c whole square, a plus b plus c whole square, a square plus b square plus c square plus 2ab. In that case you will get xy term also. Here minus 2ab, that means you will get x term, also y term, and finally c square into e square, both are constants. You will get a constant term also. Therefore, now what is our conclusion? Conic's equation is a second degree equation in x and y. So therefore, general form of a second degree equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So Conic's equation is a second degree equation. What is this? This is general form of a second degree non-homogeneous equation. Therefore, with this result, we came to know that Conic's equation is a second degree general non-homogeneous equation. We have already seen this equation. What is this? It also represents a pair of lines for some conditions. Okay, we have seen in pair of lines. So this second degree general equation, it also represents a pair of lines. For some conditions, it also represents a circle. Now we are saying that it is a conic section also. It is representing conic also. So how to find this? When it represents a pair of lines, when it represents circle when it represents a conic. Conic means there are three major conics: parabola, ellipse, hyperbola. Once we will discuss that point also. Yes. Now we have seen the equation of a conic is ax square. It is of the form second degree equation, general non-homogeneous equation in x and y. Right, this is the equation. This is known as second degree non-homogeneous equation. When it represents pair of lines, when it represents parabola, hyperbola, ellipse, etc., we will discuss now. So firstly, this equation will represent a pair of lines. Listen carefully. This equation represents a pair of lines. What is the condition? So we have seen, just a moment, we will see in first year we have seen this second degree equation represents a pair of lines if it satisfies the condition. What condition? ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. Simply we denote this condition by delta. Okay, number one, firstly, if delta is equal to 0, along with this condition, there are some other conditions for a pair of lines. H square greater than or equal to AB, G square greater than or equal to AC, F square greater than or equal to BC. These are the conditions for this equation to represent a pair of lines. We know this very well. Okay. So if delta is equal to 0, then this equation will represent a pair of lines. It represents a pair of lines. Okay. I am not writing these. They are obvious. So this equation represents a pair of lines if delta equal to 0. Further, for H square greater than AB, it will represent two real and distinct lines. H square equal to AB, two parallel lines, etc. If A plus B equal to 0, then it represents perpendicular pair of lines, etc. Anyhow, if delta equal to 0, then it will represent a pair of lines. Okay. Now, if delta not equals to 0, delta not equals to 0 means it is not a pair of lines now. So together with this, when delta is not equal to 0, if A is equal to B and H equal to 0, that means x square, y square coefficients are equal and there is no xy term. In this case, it represents a circle. So to identify circle, very simple. In the equation of a circle, x square, y square coefficients will be same, no xy term. That's what I have written here. Next, number 3. If delta is not equals to 0 and h square equal to AB, h square equal to AB, then this equation will represent a parabola, which is a conic. Of course, they are also conics. So, when delta not equal to 0 and h square equal to AB, then it will represent a parabola. Next, if delta is not 0 and h square is less than AB, then the curve will be an ellipse. Then it will be representing an ellipse. Next, number 5. Again, if delta not equals to 0 and h square is less than Here already less than h square is greater than AB. Then it will represent another conic known as hyperbola. So this is the way of differentiating conics when equation is given. You please observe. So in first condition delta equal to 0. Here delta is 0. For the remaining delta is not 0. For example, in objective question an equation is given. You have to find it represents which curve. You see the options. If pair of lines is not there in the option, then it is a very simple question. No need to find the delta because pair of lines is not there in the option. That means the equation should represent one of the following four. All the four they contain delta not equal to 0. No need to find a delta. For circle it is very simple. By watching itself you can decide circle's equation. X square y square coefficients equal no xy term, like that. So for parabola ellipse, in that case this condition is enough. If h square equal to AB parabola, less than AB ellipse, greater than AB hyperbola. So conic section, this is the introduction of conic section. We have seen definition and also seen different terms. We have seen the terminology of this chapter. So what is the equation of a conic? It is a second degree equation. If a second degree equation, then it also represents other curves. How to know those two? When it is a pair of lines, when it is a circle, etc. we have seen. So this is the introduction. Especially that terminology is very important. Focus, directrix, eccentricity, vertex, axis, center, latus rectum, focal chord, focal distance, double ordinate, etc. Not only definitions, you could able to identify in the figure which line is axis, which point is vertex, where is focus, where is directrix, etc. If you study properly, systematically in order, then definitely I assure you that it is a very simple exercise, simple chapter. Right, okay. In the next video, we will begin our first conic parabola. Okay, thank you.